Hey, we have here today another integral from the MIT Integration Bee 2010, problem 24. We have the integral of 1 over ln x minus 1 over ln x all squared dx. Okay, I thought this was really interesting. When I first looked at it, the approach didn't really jump out to me, except for the fact, now when we have an addition or subtraction here, you could split it into two integrals, but it makes me think they didn't really want you to do that, and it makes me think there's some way to relate these two. And I mean, clearly they're really similar, each expression, right? They both have natural log in the denominator. When I see something like this, there's really like two things I try. I can either start taking the derivatives of either expression, or we could try to use integration by parts. I think either method works fine here, but what I wanted to do, I kind of like just looking at the derivative. So what I wanted to do is focus on this, and let's just see what the derivative is going to be. So what I'm going to do is, instead of writing it like this, I'm going to write it as ln x to the minus 1. So I'm taking the derivative, we're going to have minus 1 natural log minus 2. And then when you chain rule on this, derivative of ln x is just 1 over x. And then just rewriting it a little bit to get it more looking like this, we can write this as minus 1 over x, 1 over ln x squared. And the thing that jumps out, of course, is really we have our minus sign there, and we have this, which is exactly this, but we have this extra 1 over x term that we don't want. What if instead of taking the derivative of this, we took the derivative of x over ln x, because then maybe we'd have an extra x and it would cancel with that. So I think let's try it this way, and then maybe we'll get the cancellation of this x, and then we'll have that term exactly, and maybe this will all work out. But again, I'm just going to write it into this form here. So now we'll take the derivative, but now we're using the product rule because we have two terms. So the derivative of x is just going to be 1, so we're just going to have this ln x minus 1, then plus we'll have our x, and now we'll take the derivative of ln x minus 1, but we just did that. Okay, so it's just all this stuff here. So I'll write this all in parentheses. We're going to have minus 1 over x, 1 over ln x all squared. But then this, we could write this just the way we have it here as 1 over ln x. We'll take this minus sign out here. We'll have minus, x's are going to cancel, and we have exactly our integral. So if differentiating this gives us our integral this, then our solution is just going to be x over ln x plus c. Like I said at the beginning, you could do this, you could use integration by parts on this, and it'll work out the same. Either way, I think they're both good methods. So we'll stop it there. Thanks everyone for watching. Have a great day.